I'm happy to be here today, and we'll talk about reducing on-site emissions on the flow of the previous speakers. We have something that accompanies the buildings from the productions to the constructions to its until life, until the destructions, is the tools, the power tools, the light equipment that you have to use to make it. So we took a study case from one of our customers who decided to go on to remove the carbon emissions from his job site from some tools. I don't want to go on the details because you all know that, but it's just to put in the context that when we say that we have to reduce by 30% in 2030 our emissions, what that means. I mean, for me, individual, for my companies, what is my share here? What do I have to do for that? So if you see the three examples here, we have Saudi that has to reduce by almost 500 million tons the CO2, and the UAE it's 203 million tons. So how we do that and what we can do for that. So first, the methodology is very simple. We go to see for analysis the footprint of a job site. So we see what equipment are there in terms of tools, power tools, light equipment, and we propose to replace that by the new technology that it's available now. So it's battery operated tools and light equipment. So first we do that, we proceed to some testing. You have some pictures here, so that's all battery operated, it's all 100% zero emissions tools. You have, in this example, tower light that you can use inside, outside. You have concrete vibrators to pour after the pouring of the concrete, and you have, in this example, 355 millimeters saw that is used to cut rebars, concrete pipes. So when we do the proof that works at least as the same level at what they have on the job site, we proceed to some more analyze and benefit. On the top of the financial benefit to not have petrol to put in the machines every day, you have a lot of other benefits, like the maintenance. You don't have any maintenance because there is no engine, no petrol engine, so no oil to replace, no spark plugs, no air filters. You also have no heat generated by the thermic engine. You can use indoor. You don't have any noise. You don't have any emissions. No fumes also. So you have a lot of advantages that are issue from this technology. You also have, you don't have the needs to bring the petrol on the job site. So no need to transport it to a special place to store it, to have extinguishers, because you don't need it. In this example, we took 3 items. It was the first stage for this company. So they moved those 3 tools from their job site. You have the tower light, 27,000 lumen tower light. You have concrete vibrators, and you have this saw. So to give you an example, the tower light is one of the worst light equipment we can find on our job site. Per year, it gives 4.2 tons of CO2 in the atmosphere. Just one tower light. We have thousands and thousands of those in our job site today. You have the concrete vibrators. It's 1.25 tons per year. And you have the saw. It's half tons per year. So on the 3 years, that's the calculations we took because it's the life cycle of a battery that we have. That gives you the reduction. So the total for those 3 items, only 3 items, this company has 50 tower lights, 65 concrete vibrators, and 20 saws. It gives them an economy of 905 tons on the 3 years, more than 300 tons a year that is completely offset using a technology that exists today, that it's available. That's the equivalent of 1,000 small trucks or vans that you have. A job site average have 55 equipment, light equipment tools, here is just 3. So imagine if you can remove from one job site the 55, the economy per job site that you can do, you can offset on this. We took the example of UAE. UAE has to reduce by 203 tons in 2030. If we just move from the job site 100,000 of those tools, you achieve already 1% of the target of UAE. And on the pictures behind me, you have a lot of equipment that you have. Also, landscaping, it's a big chunk of the CO2 emissions. Those motors are very basic. It's not like our car with fantastic injections and exhaust system. Nothing is there. It's very high in terms of CO2 emissions. We also look at the financials, okay? Because it's one thing to say that I can avoid all my CO2, but how much is the cost of that? And the good news is that there is no cost for that. The example behind me is the example of the tower light that we choose to use for 200 days a year. Most of the job sites use more than that. And we took the example of the liters of petrol of $1. Here it's 1.1 today. So the total cost on 3 years is $12,000. That's your petrol cost. If you compare that to the battery price that you need to drive those machines for 3 years, you have to buy the set of batteries, so 2 batteries, 1 chargers. It's $1,600, and after you have to charge it, it's only $0.15 to charge a battery. So on the same period, you will save $10,000. $10,000. After that, you have all the hidden costs, the rest of the cost, the oil, the spark plugs, air filter, breakage of your motors, extension, cable extensions, another $3,000. So it's $13,000 per tower light that you can save on the period of 3 years using zero emissions solutions. So that's a big chunk. That's why even if the product is probably 20% more expensive than a normal petrol tower light, it's paid in few weeks. So I think it's a no-brainer to move to zero emission solutions. To summarize, just changing those 3 items from his job site, our customers remove 905 tons on 3 years of CO2. And save $931,000, almost $1 million, 3 items. You have 55 items average on a job site. So you offset the CO2 and you save some money. So it's the best equations, I think. And those products are accompanying the full cycle of the life of the buildings, from the facilities and maintenance after the constructions until the deconstructions. On the top of that, and to encourage people to move or to switch, if I can be so, on those type of technologies, we are planting trees. So we are planting 100 trees per MX solutions that are sold for the next 200 solutions, 200 tools. So this means 20,000 trees. 20,000 trees is the definition of a forest. So we choose a project in Madagascar, so to do a reforestation of Madagascar. We will plant those 20,000 trees in a few months, which is another 800 tons that you can offset, because we saw before that you cannot always remove completely your CO2. You're obliged to compensate it. So with this, you can compensate a portion of your CO2 emission that you are obliged to do for now.